proudly sponsored by the Department of Education and Fiber VT Africa Holdings and other holding companies. To interact with me, please remember to log into HelloSmart to take part in these assessments. Interact with me. We work together in these assessments and we see how we understand these questions. You sign up as a guest. You type in the class ID as 598751. That will be the class ID for all assessments. So you add your name and we interact. Today, we take a look at the periodic table of elements. It is something I am very sure you already might have heard of some in your previous grades. Today, we introduce it and define it a little better. So in previous sections, we've been discussing matter and materials. And when discussing matter and materials, we've described chemicals, we've described materials and matter and a range of terms, properties of materials, properties of matter. So in this lesson, we are going to look at elements making up these chemicals, making up these substances that we've been talking about in matter and materials that make up those acids and bases that we're discussing. So we're going to look at individual elements that make up this particular substance or the substance we have in the world. So the periodic table is a classification system, as in a table that says things should be arranged like this. It arranges elements that we find in the world, right? All the elements that exist are listed and tabled in the periodic table, and they are listed and tabled in a particular manner. So the periodic table is a classification system that takes the elements we have in the world and puts them in a particular order. And what's an element? Of course, an element is a pure substance that cannot be broken down further. Here we have an example of gold. Gold cannot be broken down into other things. Gold consists or is gold as it is. What do I mean by breaking down substances further? Let me have an example of when you're having water, we know the symbol to be H2O. This is the symbol for water. Chemical formula for water. This is a chemical formula for water, or chemical symbol for water. Chemical formula or chemical symbol for water is H2O. So water, when we look at water, it's made up of 2 atoms of hydrogen and 1 atom of water, right? 2 atoms of hydrogen and 1 atom of water, meaning you can break down water to have it as hydrogen, hydrogen, and oxygen. So making water not an element because it can be broken down further, but it is a substance and it is a pure substance, but it cannot be broken down further. So an element is a substance that cannot be broken down further. Gold, as beautiful and as pretty as represented in the picture, being one of the examples The chemical symbol for gold is AU, right? So this cannot be broken down further. This is AU as it is, and it exists like this, and it stays like that. Let's have another like carbon. Charcoal. Carbon has symbol C. Chemical symbol C. So having chemical symbol, this is an element that cannot be broken down further into anything. You cannot break this down further into anything else. It remains as it is, making it carbon as well as gold pure element, right? So we know what an element is. These are pure substances that cannot be broken down. So all of these pure substances come to make the substances or chemicals we have in the world. So we're gonna be having water, salts, sugars, glucose, and all of these are made up from individual elements reacting in a particular way to make that particular substance. So we in this lesson look at individual elements, those individual elements that come together and make that particular acid, to make that particular base, to make that particular mix, to make that particular substance. So we have these individual elements before they come and react to form substances. They exist as pure. So we look at these pure elements, and as introduced at the beginning of the lesson, these elements are arranged in a particular way, in a particular manner, in table form called the periodic table. The periodic table was introduced or was first proposed by this Russian scientist called Dmitry Mendeleev a very long time ago in 1872. He suggested a system in which we can tabulate or arrange our elements. And at this time, not too many were known as we discover more and new elements as time goes as scientists. So he arranged a way in which, a system in which, even when we do find more and more, we can easily arrange them using this particular standard developed by Professor Mendeleev. So how he proposed this was such that we have a system of elements that make up matter and material in the world. So today there are more than 100, and each element has a particular name, has a particular symbol, atomic number, as well as a position in the periodic table. Right? It will be tabled and in a particular, it will be situated in a particular position in the periodic table. It will have a unique symbol as well as a unique atomic number. Looking at the image on the board, we have 4 elements. We have sodium, magnesium, potassium, and calcium. Looking at all these, they have what you have just called them out: sodium, magnesium, potassium, and calcium. They have unique symbols. Sodium as its unique name. And it has the symbol Na. Has atomic number there identified 11. And finally, has a position in the periodic table, and we'll look into that a little later. So this is the symbol, and this is the atomic number. Right? So each element will have a unique name, a unique symbol, a unique atomic number, as well as where it will be positioned in the periodic table. Let's look at the chemical symbol. Chemical symbols of elements will usually begin with the first letter of that element. For instance, zinc. Zinc has symbol Zn. Like carbon, which will have the symbol C. Like nitrogen, which will have the symbol N. Like hydrogen, which will have the symbol H. So atoms will normally, or more often than not, the name represented by a symbol that is the first alphabet of that particular element. Looking at carbon, it will have symbol C. Looking at nitrogen, it will have symbol N. Hydrogen will have symbol H, right? So that's one way for us to know what will be the symbol of this particular element that I'm trying to name. So you'll be given an element, and in knowing its symbol, you'll remember that most elements will have a symbol that is the first letter of that particular element. And that symbol will be represented by a capital letter. A capital letter C for carbon, a capital letter N for nitrogen there, and hydrogen, uppercase H. Uppercase H, or capital letter H. And that is the symbol for hydrogen. Let's look at these other elements as well, and look at the names associated with them. Nitrogen, we said, starts with N. Oxygen should sure start with O. Phosphorus should sure start with P, right? Let's look at hydrogen, already discussed as starting with H. Carbon, already discussed as starting with C. Zinc, Zn. So you must be asking yourself, what happens when now you have a symbol having an element having a symbol that is not one letter but two? What happens when it's having two? What would be happening? Why? So we have elements having two alphabets to its symbol because we have elements that have the same alphabet. An example is here. Let's look at calcium and carbon like this. Calcium and carbon start with the letter, both of them. So as we discussed earlier, each element needs to have a unique name, symbol, atomic number, as well as position in the periodic table. So calcium and carbon, two unique names. Yes, they're both elements. As to the symbol, how can we find the symbol for calcium? And so what happens is carbon has symbol C already. So what symbol can calcium have? Calcium. Will calcium also have a symbol C? No, it may not. It can't, because it would now not be having a unique name to it, a unique symbol to it. It would be having a similar symbol to carbon, which can be confusing. So with calcium, there's an A there to represent or to differentiate calcium from carbon. Let's look at bromine. There's bromine here. Bromine having symbol Br. For bromine to have symbol Br, it's because first we have boron with symbol B. We have boron with symbols B, forcing us to have bromine as Br, where B is the first letter of the alphabet and R is the second letter of the alphabet, allowing Br to be the symbol for bromine. So boron will have the symbol B and bromine will have the symbol Br. But what happens with elements that has a symbol that is different from its name? Let's look at sodium. Here's sodium. So as SODIUM, but has symbol Na. Why is that? Sodium comes from the Latin name for sodium, Na. This comes from the Latin name for sodium. Do you remember that most of these symbols were discovered a very long time ago, when most things were studied in Latin? So sodium comes from its Na, which is the symbol for sodium, comes from its Latin name for sodium, which is natrium. So they took the N, which was the first alphabet, of course, but because nitrogen is already N, they added the A, and they called it Na, right? So that's the very same principle, but they chose Na because this was called natrium, which is Latin for sodium, but we know it as sodium because we are now studying in English and no longer in Latin. Elements such as silver, gold, potassium, tin, iron. These are elements discovered around that time, a very long time ago when we were studying these in Latin. And these are the few that will have their symbols different from their names. And these here, these five would be the five that upon knowing the symbol and the name, it becomes easier to know the symbol and the names for the rest of them, for the others. These are the unique cases where the symbol and the name are very different. And in knowing the others would be easier to know or memorize. And in grade 8, or continuing now, I would advise that you try to look at I will have a periodic table slide where knowing the first 20 elements of the periodic table is advisable. You need to know the first 20, at least the first 20 elements of the periodic table. So some simple rules to remember the chemical symbols, right? Every symbol has its own unique every element has its own unique symbol. We discussed how every element has its own unique name, symbol, atomic number, as well as position in the periodic table. Looking at hydrogen and the first two elements in the periodic table will have first unique names. Secondly, unique symbols. What are these? Of course, atomic numbers. They must be unique atomic numbers. Well, for hydrogen has unique number, atomic number 1, and helium has atomic number, and how they are arranged as 1 and 2, meaning elements are arranged in their atomic numbers. So we are still looking at simple ways to remember chemical symbol. The symbol is usually the first one or the first two letters of the name of the element. So hydrogen has H, as the helium has He. It would be H, but H wouldn't be unique because H already belongs to. So it is He for helium, meaning the first two, right? So elements have symbols of elements will be the first alphabet of the name or the first two alphabets of the name. The first letter of the symbol is always in capital letter. It's always uppercase. And the second letter, when it does have a second letter, when the symbol of the element does have a second letter, it will be now lowercase. Some elements have symbols that are in Latin, as discussed. So that would be the difference. Going back to our table, here we are talking about those elements that have their symbols coming from their Latin name, right? Those leads, those tins, those silvers and golds, potassium. Those are the elements that have their names or their symbols coming from their names that are in Latin. But even so, they are like this because they took the first letter and it's a capital, and they took the second letter from the name such that the symbol is unique to the element. So looking at these simple rules to remember how to remember when using chemical symbols. Let's look at the first one. It's saying every element has its own unique symbol. Looking at our table, these elements have unique, meaning no two elements will have the same symbol. Each one has to have its own. Aluminium, Al, bromine, Br, calcium, Ca, carbon, chlorine, copper. These four start with element or start with letter C, but all four will have different symbols. Where calcium is Ca, carbon is C, chlorine is Cl, copper is Cu, right? Or copper as well. You would expect copper to have the symbol of Co. Of course, actually you have to have C, but C already belongs to carbon. Why not CO? CO would be great, but copper, the symbol comes from its Latin name, making it Cu. So each symbol is unique. Number two, what's number two? The symbol always has the first alphabet or the first two alphabets representing the element. With aluminium is the first two, with bromine is the first two, calcium the first two, carbon the first one, phosphorus the first one, oxygen the first, nitrogen, and so on and so forth, right? As represented in the table. Sulfur, it's the first one. The first letter is always uppercase. Looking at these, the first letter is always uppercase for all of them, whether it be having one, whether it be having two elements. The first letter will always be uppercase. The second letter, and then this is when it has letters to its symbol. The second letter is now lowercase. Second letter is lowercase and the first letter is uppercase. Aluminium will be A uppercase, L lowercase. Bromine will be B uppercase and R lowercase. Calcium, chlorine, copper, gold, so on and so forth. And as discussed, some elements will have their names coming from their Latin. So looking at the periodic, we will further go on to look at why are these arranged in this particular way. In this section, we discussed the symbol, and in our next session, we'll be discussing the periodic number as well as the position of the element in the periodic table. Here we said the periodic table is a classification that shows us how the classification system that shows us how elements in the world that we find are right. It arranges them for us. It arranges them for us, and each element will have a unique name, symbol, atomic number, and position in the periodic table. In this session, we looked at the name and the symbol. In the next session, we look at the atomic number as well as the position in the periodic table. And we start to build our periodic table. We will then start to build our periodic table, starting with the first element, second, third, and how were these arranged. And in our next session, we're going to be having a small activity to engage with. So please remember, you need to log into hellosmart.com. You sign in as a guest. You use this class ID. You add your name and we interact. Tomorrow we're going to be looking at the atomic number and the position of these elements. Today we discuss the name and the symbol of these elements. We know what an element is. We know that an element is a pure substance that cannot be broken down further. So these are arranged in a particular way in the periodic table, and each one will have its own name, symbol, atomic number, and position in the periodic table. So tomorrow we'll look at the atomic number as well as the position in the periodic Thank you.